Okay, now we are going to learn about period changes. If you think about, like in hockey, there are 3 periods having to do with time. So that's what we're going to be looking at here is time. How long does it take to cycle one time around the unit circle? Okay, and if you remember back to our parent graph, that happened in 2 pi. So we're going to fill out our parent graph here. Again, sine at 0 is 0, at half a pi is 1, back to 0, negative 1, and 0. Okay, you should kind of be getting the hang of that sine graph because the parent graph, that's what we're going to compare it to always. Now if you notice, our x-axis is labeled all the way up to 4 pi. So this time we want to cut it in 2 pi, 1 pi, and 3 pi, but then we also have to cut these in half also. Our y-axis is labeled from 1 to negative 1. So if I do my sine graph, we have 0, 0, half a pi is at 1, pi is at 0, 3 halves of a pi is at negative 1, and 2 pi. Again, looking at the curvature of the sine wave, and it finishes in 2 pi. Does it keep going on forever and ever? Yes. However, one period is done in 2 pi. Okay? So now look at what happens today. Where is the number? The number yesterday was outside of the function. Today it's inside the function. So what we're actually looking at is multiplying this first, then finding the sign. So 2 times 0 is 0. The sign at 0 is still 0. However, what it's actually doing is, how do we bring it back to half a pi? Well, it's kind of like the opposite. What's the opposite of multiplying by 2? Dividing by 2. So if I divide or cut half a pi in 2, I'm at 1/4 of a pi now. And that's where our 1 is. How do I cut pi in half? Half a pi. We're back to 0, negative 1, and 0. So it's like taking all of our sine parent x's and we're cutting them in half because we're reversing it. We're trying to undo that times 2. So what happens here now is ultimately we are done with one cycle after pi. So we have 0, 0, 1/4 of a pi, half a pi, 3/4, and back to pi again. And now my pi cycle was done in a period of 1. Now here's how I like to look at it. How many of these would it take to finish out to 2 pi? See how there needs 2 of them? There's where that 2 also comes in. So theoretically, if I just said I needed 2 to finish out in a regular parent cycle, how many am I going to need to finish here? So you think it's probably going to be 4, right? So again, let's look at this. How do I undo multiplying by 4? I divide by 4. 0 divided by 4 is 0. Half a pi divided by 4 is an eighth. Pi divided by 4 is pi over 4. This becomes 3/8 and half a pi. These numbers over here are not changing because it's inside the function. So now ultimately, look at what happens here. By the time I hit a half a pi, I am already done with one cycle. So how many of these do I need to get to 2 pi? There's 2, there's 3, and there's 4. So there's the 4 times the amount. So it's going to speed up my sine wave. So if putting a whole number inside the function speeds it up, so the period here is at half a pi, what theoretically do you think is going to happen when I put in a fraction or a decimal? So now how do you undo? This is kind of like saying sine of x divided by 2. How do you undo dividing by 2? You multiply by 2. So if I go back to my parent graph, 0 times 2 is still 0. Half a pi times 2 is now pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3. And 2 pi times 2 is 4 pi. So these double. And again, the amplitude is not changing this time. It's the period or the time change. So what happens now to my sine wave is it slows down, and I can only get half of the wave done by the time I normally have a parent graph done. Half of the wave is done by the time I get the parent. 4 waves are done by the time I get the parent. 2 waves are done by the time I get to the parent, and I only had 1 wave done here. So that's another way to look at it. The period here is 4 pi. It took that long to complete the cycle. So in summary, to change the period or the time, you have to multiply a number inside the function. So B is my period changer, and what was A? Our amplitude. Now, this will help you to calculate the period. Period equals 2 pi divided by the absolute value of B. Okay? B was this number right here. So if you think back to if I said the sine of 4x, well, what is the period? Period equals 2 pi divided by 4. So the period is half a pi. That's another way for you to kind of figure that out. Okay? So for a sine or a cosine graph, this is the best way to look at it, but the period of a parent function is 2 pi. So if you turn the page, okay, I'm going to skip number 1 and I'm going to look at number 2. What's so different about number 2? Well, first of all, we're going to be using the cosine's parent graph. Second of all, look at what B is. B is 2 pi. So if you want to, I would write down the parent graph. Okay, typically there's our XY chart. Normally we use pi, half a pi, or 0, half a pi, pi, 3 pi over 2, and 2 pi. And typically the cosine graph starts 1 high, goes to 0, -1, 0, and 1. What is period change affecting? It's affecting the x side of my graph right here. So I need to change that by finding the period. Remember we said that period equals 2 pi over b. 2 pi over, well, what is b in this case? It is 2 pi. So what's 2 pi divided by 2 pi? 1. So I'm starting at 0 and I'm ending at 1. So how do I figure out all these other pieces? Well, what's halfway between 0 and 1? 1/2. And what's halfway between 0 and 1/2? 1/4. What's halfway between 1/2 and 1? 3/4. My amplitude is not changing because there is no a. Well, technically there's a 1. So I'm going to be going 1 high and -1 low. My period is going to end at 1. Halfway is 1/2. There's 0. There's 1/4 and 3/4. So my sine wave starts at 0, 1, 1/4, 0, 1/2 pi -1, 3/4, and up to 1 again. And remember, the cosine wave still curves, it just looks different. So what is the period? Well, when did it start and stop? At 1. What is the amplitude? How high did it go and how low did it go? 1. What is the domain? Well, this continues to go on forever and ever and ever. So my domain goes from -infinity to +infinity. My range goes as low as -1 and as high as +1. All right, if you turn the page, I'm going to do one more with you, and I'm going to do number 4, because now we have amplitude changes and period changes. We're back to sine again. So my parent graph or t-chart is 0, 1/2 pi, pi, 3 pi over 2, and 2 pi. And the sine wave starts at 0, goes up to 1, back to 0, -1 and 0. Okay? Amplitude affects the y side of the chart. Period affects the x side of the chart. So if you think about amplitude, I'm going to take it and stretch it by 3. So I'm going to multiply all of these values by 3. 0 times 3 is 0, 1 times 3 is 3, back to 0, -3, and 0. The period, remember to find the period. Period equals 2 pi divided by b. Well, b is 2 this time. So my period is at pi. So I'm going to start at 0, but this time I have to end at pi. So I'm cutting all of these in half. Half of pi is half of pi. Half of a half is a fourth. So it's like we're counting by fourths. 1/4, 2/4, 3/4, 4/4. And now that is my new XY chart right here that I'm going to graph. I'm going to go as high as 3, as low as -3. I'm going to end at pi and cut all of this in half. So I have 0, 0. I have 1/4, 3, 1/2 pi 0, 3/4 -3, and pi back to 0 again. And there is my sine wave. Now, how many sine waves would it take to get to 2 pi? 2 of them. So now, what is my period? It started and stopped at pi. What is my amplitude? It's from the midline, 3 high or 3 low, but it's a distance, so it's always positive. My domain starts and stops from -infinity to +infinity, but my range does have a definite end at -3 and a definite end at +3, and that's why those are in the brackets. So hopefully you have